Okay, so going through question 1, simplify y to the power of 8 times y squared. When they're times in the indices, you just add them together. So first one should just be y to the power of 10. The next one, expand and simplify the following. Well, the first thing we need to do is expand it. So that 5 needs to multiply both bits of there, and that minus 2, and be careful that it's a minus 2, needs to multiply both bits of that. So we get 5 times 3x, that would be 15x plus 20. We get minus 4x and then minus 14, and then we'll put together everything. So we've got 15x take away 4x, that gives me 11x, and plus 20 take away 14 is plus 6. Nth term here. So for number 2, we've got up in 4, then 4 again, then 4 again. So it is what we call a linear pattern. So that means whatever it's going up in becomes that n, so 4n, and then I go and find the number in front of the first term. So if I'm going up in 4's coming this way, I must have gone down in 4's this way. So I would have 3 take away 4 would be minus 1, so that minus 1 just gets plonked on the end there. Now this one here is a little bit sneaky. It's saying what is the nth term for this? Well, you could guess the numbers what would be next. It would be 5 times 7, then it would be 6 times 8. In terms of this being the first term, first, second, third, and fourth term, then the nth term, so when it's the first term, it's 1. When it's the second term, it's 2. When it's the third term, it's 3. When it's 4, it's 4. So when it's n, it will be n times. And if you look at the link between this one here, what's different about here? Well, this number is always 2 more. So it's going to be n plus 2 in a bracket. Number 3. On graph paper, draw the frequency polygon to show this data. Okay, so the key word there, frequency polygon, you've got to know 2 things. First thing, it is a line graph. Second thing, it is plotted at the midpoints. Okay, so looking at the frequency, the highest frequency I've got is 34. I can see what the graph paper wants me to do here. It probably wants me to go up in 5, so 5, 10, 15, 20, 25, 30, 35. Yeah, that'll work. And then it starts at 3 and it ends in 27. Okay, so probably want to go up in 5s again, 5, 10, 15, 20, 25, 30. Yes. Okay, so the number of words is going to go on the bottom. 5, 10, 15, sorry, I'll show you what I'm doing, 20, 25, and 30, and that would be my W, which they've called it by here, they've called it W. And then the frequency needs to stop at 35, so just coming along the side here, is that showing it? Yep. 5, 10, 15, 20, 25, 30, 35. Remember to label the axes. So that is frequency. Okay. So what I'm going to do here, because I know I've got to plot the midpoint, I'm going to say above here, MP. So the way to find it is the number in between 3 and 7. So the way I'm going to do it is add them together and then divide it by 2 to halve it to find what's in the middle. So 3 add 7 is 10, halve it is 5. 8 add 12 is 20, halve it would be 10. 30, halve it, 15, and then 20, and finally 25. And then I need to plot those points at that frequency. So I need to go down to 5 and up to 13. So down to 5, up to 13. There's 12 and a half because it's in between 10 and 15. And again, if I worked out my scale, I've gone up 5 in 10 little squares. So that's 0.5 is 1 little square. Okay, so just what I'm doing there, 1 little square. Okay, so 5 and 13, I've got 5 and 12 and a half, so go up 1 there, there. And then 10 and 23, so across the 10, up to 23, so that's 22 and a half, 23. And then we've got 15 and 34, so that's coming up right to the top now. That's 35. If we come down to, that would be 34. And then 20 and 18. So again, I'm going to come to 20, halfway, 17 and a half, up 1. And then 25 and 12. So there's 12 and a half, down 1 would be 12. Okay, now what I should have now is a ruler. Make sure you use ruler in the exam. Technically speaking, I shouldn't have used pen there either. If you make a mistake in the exam, you're going to find it very hard to correct that on the paper, and you could destroy an awful lot of good work. And then the way I remember it being a frequency polygon is that I think that if I did join up those last two there, I would make a polygon, a many-sided shape, but you don't join up those last 2 points. Okay? All right then, moving on to question 4. Okay, now these come up pretty much every year. Express 500 as a product of prime factors in index form. So the key things you want to know, that basically just means factor tree. Okay, so factor tree, 2 numbers that multiply together to make 500. So I'm going to go with 5 and 100. If it ever ends in zeros, that's always the trick I use. The prime numbers need to be circled. So 5 is a prime number because it only has 2 factors, one in itself. 100 is not loads of numbers going to 100. 10 and 10, 25 and 4, 50 and 2. I'm going to go with 10 and 10. Now, neither of those are prime again because they end in 0, so I've got to branch off from the 10. Now, the most common mistake here that will be done correctly is people write 5 and 5 when it should be 5 and 2. 5 times 2 makes 10. The same here, 5 times 2 makes 10. Now they're all circled, I've got nowhere to go, so I write finally 500 equals, and you should write this out in the list first, 2 times 2 times 5 times 5 times 5. It's all of these numbers in the circles, and I write them in ascending order, so smallest up to the biggest. And then I write it into its index form, which it did ask me to do that in index form. Okay, so that would be 2 squared times 5 cubed. Okay, and then it says right down here, so this is a totally different question, part B. It says write down the least positive whole number that 3 squared times 7 cubed must be multiplied to make the result a perfect square. So to be a perfect square, I'll try and highlight that with there. To be a perfect square, your definition is indices must be even. Okay, so indices must be even. So anything without an even indice, I need to multiply that number by. So that 3 there, although the 3 is odd, the indice isn't. The indice is 2, which is an even number. The 7 is odd, and so is its indice, so I must multiply by the 7. So times by 7, or just saying 7. Okay? Number 5. Okay, draw the reflection of the triangle ABC in the line y equals x. Okay, so the line y equals x is a diagonal line where the x value, so 1, would have to be equal to the y value, also 1. And then x value 2 would have to be equal to the y value 2. Okay, and so on. So basically it creates this lovely diagonal line, so make sure you draw this correctly, because if you don't, you've lost your mark straight away. Now, tracing paper is a great way to do this, and you do get given tracing paper in the exam. It's a bit nasty that it's a diagonal line. For me, I'm going to do the count to the line and then go the opposite way direction. Okay, so for B, the way I get to B is I go across 2 there, so that means I need to go down 2 now. So B's new one will be there. I'm going to call that B dash, just to show that I've done B. And then again, if you look at it, 1 diagonal box here, and that's gone across 1 diagonal box. So it's sort of like the shorthand way of doing it. So this way, 1, 2, 3, 4. So when I draw that now, it needs to go 4 the other way. 1, 2, 3, 4. So I'm going to call that C dash because I just did C. And finally for A, it's going to be down 1, 2, 3, 4. And then I need to go across 4. Hang on, where was I? A. 1, 2, 3, 4. 1, 2, 3, 4. That's what I'll call that A dash. And then you just join up your coordinates. Now, the best thing for you to do to see if it is a true line of reflection, you won't see it the way it's drawn there, or maybe you won't see it obviously. If you change the paper, look at that, it does look like that's been folded upon itself. Okay, so if I've got it for me, or is it maybe even better there, just like a straight line like that, you can see it's quite clearly just been folded upon itself. Okay then, tracing paper again, I probably should be a little bit more prepared, but as it is half term, I've forgotten to do this in advance. It says the clock rotate triangle D 90 degrees clockwise about the point -1, 2. So -1, 2 is across to -1, and then to 2, would that be that point there? So what I would do if I had tracing paper is I'd draw a crosshair over it like that. I might be able to grab some quickly. Yeah, I've got some. Okay, so getting a tracing paper. So at that point -1, 2, sorry if you didn't see that on camera then. So the point -1, 2, if I go and put my tracing paper over it, I trace both the crosshair, in fact I'm going to use a better pen, and the triangle, okay? You should trace both of them on your tracing paper. And then what you do is you put your pen on that crosshair and you rotate it around until you can see that crosshair turns it into 90-degree splits. So I need to go 90 degrees clockwise, so the way the hands move around the clock, so that's this way. So that would stop by there. I should just about be able to see my triangle through it. So if I do that one, and then one on the top, and then I draw those points together. It said label it E, didn't it? So I have to label that as E. There is another way of doing it. If you look at this one here, how did I get to that point? So I went down 1 and across 1, 2, 3. This time I've gone down 3. Hang on, have I made a mistake here? Sorry, down 1 and across 2. So here, this time I've gone down 2 and across 1. And this one here, I go up. I don't like that method. I much prefer the tracing paper, and you'll be given the tracing paper in the exam. Okay, next question. Tend not to see a huge amount of these now. It's loci, this question. It says the diagram shows a piece of cardboard. It is fixed to a drawing board by a drawing pin at A. Draw the locus of the point B as the cardboard turns around A. Okay, so again, I need a compass for this. I'll just run and grab my compass as well. So the key word was that it was turning about A. So what I want to do is open my compass to here. So it's getting fixed that bit here, and I can basically just move the cardboard whichever way I want. B can only move in an arc around that. So B is always going to be somewhere around here. So what I do is I hold paper still. Okay. So basically, if I did have a drawing pin fixed through that and just move that cardboard, the cardboard would actually overlap over certain bits of it, but B wouldn't. It would stay within the drawing board the whole time. This one here now says a circular disc, center C, rolled along even ground, or rolled along ground from P to Q. Draw the locus of C. So basically, if it's moving, that center is always going to remain in the center, isn't it? If it was like here, it was sometimes it'd be at the bottom, but then the next roll it'd be near the top. But when it's in the center, it's always just going to remain in the center. So that would just be a straight line around and staying in the center. And then this one here, down at the bottom. So it's in the center again. So that's going to roll down here, and then it's going to come here, and I believe it would be a straight line there as well. So I hold my ruler parallel. I'm just going to draw, and again, you'd use pencil to do this. Just draw a faint line there, and then here, parallel to that ground. Sorry, you can't see that. There we go. Parallel to the ground here, and then it's going to be where those two meet up eventually. So I'm just going to go and add on a bit more there, and a bit more here, there. Okay, so that's what I expect that center to do, is that roll down and sort of even off. Okay, next one, simultaneous equations. So I've got 2x plus 5y equals 4, and then I have got 3x plus 4y equals 13. So what I want to do here is I want to get either the x coefficients the same or the y coefficients. I'm going to choose x because they're smaller, so it'll make it slightly easier to do the question. Okay, so number one, number 2. In fact, actually, let's call this 3 and 4. Let's call this one 1 and 2, because they're already written out for me. To get the coefficients the same, I just want to multiply by the opposite coefficient. So 3 here times the top one, 2 here times the bottom one. So if I triple everything in the first line, I'm going to get 6x plus 15y equals 12. And for number 2, I'm going to get 6x, I'm doubling everything, plus 8y is equal to 26. Okay, so now I want to do either equation 3, take away equation 4, or vice versa. Whichever one leaves me with a positive y. I don't want to have a negative for my y. Okay, so I'm going to have 7y equals, by doing 3 take away 4, sorry. 7y equals, now this is going to be negative. That's not the end of the world. It's the 7y we didn't want to be negative. If that was negative, it's easier to make a mistake. 12 take away 26, well, 26 take away 12 is 14, but because it was the other way around, the smaller number take away the bigger number, must mean that it's minus 14. Okay, so then taking the 7 across to divide, I'd have minus 14 divided by 7, which would be minus 2. Okay, that's 2 of the 4 marks so far. To go and get the next mark, all I need to do is sub in, or sub y equals 2 in either 1 or 2. I'm going to choose 1 just because it has smaller numbers. So I'm going to have 2x plus 5 times minus 2 is equal to 4. Okay, so then what I'm going to do is times out the 5 times minus 2, which is minus 10. And that is equal to 4. Take the minus 10 over, so 2x is equal to 14, and then x equals 7. Now there's a really, really easy way I can check this. I can sub both those values into number 2 and see if it comes out being true. So I'm saying that 3 lots of 7 plus 4 lots of minus 2 should come to 13. If it doesn't come to 13, then I'm wrong, and I'm going to leave the exam knowing I'm wrong. Here I'm going to get 21, take away positive times a negative, take away 8 is 13, and sure enough, 13 is 13. So I know I'm definitely right, so I can leave the exam knowing I've already got those 4 marks. Simplify. Now again, we've already looked at indices in this paper. When you times, you add the indices together, but the numbers must still times. 3 times 4 is 12. And then p to the power of 3 times p would be p to the power of 4. That has got a power, it's just a 1. You don't need to write it, it's just the power of 1. And then r to the power of 6 times r squared would be r to the power of 8. Okay, factorize means put into brackets. So I'm looking for a number or a letter or both that go into them. So we've got 6 and 9, so quite clearly 3. And then a squared and an a, so that needs to come out. So basically now I'm dividing this by 3a. So how many 3's going to 6? 2. How many a's going to a squared? A times a would make a squared, and then I've still got a b left there. And remember, if I expanded that out, it should give me back the same thing. It should give me 6a squared b, and it does. And then I'm going to get plus 3, but not 3a, because I've already got the a on the outside. So remember, times it out, I should get the same thing that I've just put into the bracket, so I get 9a there. Okay, so again, no, I'm right. When I'm factorizing, it should always be the biggest number that comes on the outside. Okay. Question 9. Fertilizer is sold in bags of mass 12 kilograms. Correct the nearest kilogram. Okay, that's your key word here. Correct the nearest kilogram. This is telling me we're looking at upper and lower bounds. So I can circle the thing to the nearest. When it's the nearest kilogram, it means 1 kilogram. You halve it to get 0.5 kilograms. To find the lower bound, you just subtract it. So if I subtract 0.5 from 12, I get 11.5. And if I rounded that to the nearest kilogram, you would get 12 kilograms, because 0.5 rounds up. Now, the thing that's hard to get your head around is that you actually add it on here and get the greatest possible mass as 12.5. Which some people say, well, doesn't that round up to 13? But there's an idea that you recognize that it could be this one, and it can't quite ever reach this one here. For instance, if I said something rounded to the nearest 10, if I said 130, with what number rounded to the nearest 10, you could say, well, 125, so 4, anywhere in that range. Okay, but someone could say, well, that's 134.9. I'd still round it to 113, and then you could say 1.99999. In fact, let's say it's 134.9 recurring. And if you put into your calculator 134.9 recurring, guess what answer it will give you? It will give you 135. So the distance between them as well is 10. So it's quite an easy way to remember that whatever you're rounding to, you halve it, take it away, add it on. It can be that one. It can never quite get to this one. Okay? It then says, find the least possible value and the greatest possible value mass of 100 bags. Well, the least possible value is 100 lots of those. So I just need to do 11.5 times by 100. So that's going to give me 1150. And the greatest possible would be 12.5 times by 100. Okay, so that would be 1250. Then says for part 2, it says Chris wishes to be sure that he delivers 1,200 kilograms of fertilizer to the customer. Find the least number of bags Chris needs to deliver in order to be sure that at least 1,200 kilograms of fertilizer is delivered. Okay, so Chris needs to be really negative. He needs to be really pessimistic and think, oh, what if they're all the smallest amounts? So we know that 100 lots of least would be equal to 1150 kilograms. So basically we need to keep on adding on more of this 11.5 until we eventually get to 1200 kilograms. So if I do 11.5, so that would be 1161.5, so that would be 101. 1172.5, that would be 102. 118. Oh, hang on, I've made a mistake here. I just spotted it. That would be 1173.0 effectively, because I'm adding 11.5. So then this one here, this would be 1184.5. So that would be for 103. And then 11, and then it's going to be 11.5 added on to that. So that's going to be 1196 for 104. And then that's still not quite enough. I need to be certain. It says Chris wishes to be, certain that he gets at least that delivered. Okay. So then if I deliver 105 bags, I'm going to be 1, 2, and then 11 onto that would be 07.5 kilograms. Okay, so it says find the least number of bags that Chris needs to deliver to be sure that he has at least that. So I think I've shown enough work in there actually. I'm quite happy with that. So I'd say just to finish it off underneath something like, sorry, camera's a bit diverted here. I'd say something like 105 bags needed. Okay. Okay, and number 10. So 10A, solve the inequality. Okay, inequality is just like equations, nothing to worry about. You just have to use that sign throughout. Try to avoid any negatives. Okay, so find the least value of x. So minus 3x, minus 7x. I'm going to find the least value, which is actually the minus 7x, because it's lower than minus 3. We'll bring that round to this side. So anything else, I'm going to move around to the other side. So my positive 13, I'm going to take over to become minus 13. So that's going to give me 7x minus 3x is greater than or equal to 22 minus 13. And then that's going to give me 4x is greater than or equal to, what's that? Gone blank, 9. And then take the 4 over to the other side. X is greater than or equal to 9 divided by 4. Now, it's absolutely fine to leave your answer as 9 over 4. Okay, but if you want to, you can say equal to 2.25, and that bit might be useful for the next question. It says, write down the smallest whole number that satisfies this inequality. Well, we've just been told that x can be greater than or equal to this value, is 2.25. So that means I need to have the next number that is a whole number that's greater than 2.25, so that would just be 3. Okay, question 11 is now off the spec, so taking that one off. Okay then, this one's a bit sneaky, these ones. Similar angles and triangles. Pretty easy when they're straightforward, but they can be pretty hard when you look at ones like these. Best thing to do is go mark the angles that we know are, that are equal. And if I hold the paper around this way, it might be a bit more obvious to see. We've got parallel lines, so that means we've got Z angles. So I know this angle here would be the same as this angle. And vice versa here, I know this angle here is the same as this angle, which means that these two must be the same, which I knew anyway from opposite angles that must be equal. So looking at this one here, then it says, and we're told that they're similar anyway. Okay, it says show that they're similar. Oh, I think I've done that. So I've shown that by doing the angles. Okay, so I've not looked at this paper before to try and put you in the same sort of same position as you, what it's like when you first see a question. Okay, so I'd say as E, D, and then to B, so from E to D to B, as that angle is equal to D to B to A, and the reason why that is because they're called alternate angles. Alternate angles are equal. And then I'm going to say and DEA, so going from D to E to A, is equal to EAB. So you always put the angle in the middle. Again, alternate. That means all three angles are the same. Hence, similar. That's what the definition is, to be a similar shape. They have to have identical angles. So it says the length AB equals 8 centimeters. So from A to B, that's equal to 8 centimeters. And then B to C. So B to C, this guy here is 10 centimeters, and D to C is 15 centimeters. Calculate the length of D to E. So it wants us to find this one here. Okay, so if it was me, I can't get my head around it when it's drawn like this, so I'm going to try and draw it again, but where they look the same next to each other, so only a little sketch like right next to the question. So I'm going to have this one here, and I have the double angle there, and then the single angle there. And where the double angle to the single angle is here, that's 8 centimeters. Where the single angle is, that's 10. Okay? And then I'm going to do the same for the other triangle there. Then it's a bit bigger. I'm going to have the double angle. And where the double line is, I don't know what that is. It's where the single angle is up to the other thing. I know that's 15 centimeters. So now I've got it like that, it's maybe a bit more obvious to spot what my scale factor is. So I know that the scale factor is equal to the 15 divided by 10, which is 1.5. So that means to move from this triangle here, the small one, to get to the big one, I've got to times everything by 1.5. So I need to do 8 times 1.5 to work out what the base of that new triangle is. Just write that down here. 8 times 1.5. And then half of 8 is 4. And then times it by 1.5 would be 8 add 4. So that would be 12 centimeters. Okay? So 12 centimeters that. Okay, and cumulative frequency. So without even reading the questions, I'm expecting median and interquartile range to come up here. And then if I go and, so what does the question say? It says 60 pupils given a task to complete, times recorded. Here are the results summarized in a cumulative frequency polygon. So sure enough, it says A, find an estimate for the interquartile range. So interquartile range is the upper quartile subtract the lower quartile. Giving full details, find an estimate for the number of pupils to take between 20 and 30. Okay, we don't usually see that come up many times in recent papers. So it says find an estimate for the interquartile range. So interquartile range, see what I'm doing here, IQR, interquartile range is equal to the upper quartile, take away the lower quartile. So the upper quartile is 3/4 of the cumulative frequency, and the lower quartile is 1/4 of the cumulative frequency. So if I look at my graph here, the cumulative frequency goes up to 60. 1/4 of 60 is 15. So what I do is I just draw a line from 15 until I hit my curve, which I can quite easily see it's there. And then I'm going to mark that as 15 as well. And I'm going to already call that the lower quartile equals. And if I come down and read off this value, now I need to read the scale here. I can see that it's come too short of 25. So some people say, oh, it's 23. It's not. Read the scale. It's the same scale as the one I worked out before. It's 5. It's a jump of 5 with 10 little squares. So that's telling me that each little square is worth 0.5. So come back 0.5, 24.5, 24. So the lower quartile is 24. And for the upper quartile would be 3/4 of the cumulative frequency. Okay, so 3/4, well, 1/4 is 15, so 3/4 would be 45. So I go and find 45, do the same thing again. And again, I call that UQ, and that was 45, wasn't it? Is equal to, and I come down, read off what the value is. It's not working particularly well with the computer in the way. Leave that for a second. So if I come down and read off that value, that's 30, so 30.5, 31, 31.5. So that means my upper quartile is 31.5. So my interquartile range is 31.5, take away 24. A couple of different ways that you can do that. If you're doing it mentally, for me, I'd add 6 to get up to 30, then add 1 to get up to 31, then add 0.5. So I've gone up 7.5. Okay, but if needs be, I could do a variety of different methods there. That's just my personal preference. It says, giving full details, find an estimate for the number of pupils that take between 20 and 30 minutes. So what I need to do is look at how many people got at 20, how many people got at 30. Okay, so I'm interested in how many people are on this bit of the graph here. Okay, so if I come and read off, again, sorry about the camera, I'm just going to do this to make it a bit easier for myself to begin with. And I read off what that value is there, and I read off what this value is here. So I've made that as 9 and 39. Well, if I was on 9, I've gone up to 39, I've added 30. So I'd expect 30 people to be the answer there. And when it says giving full details, maybe I should have said 39 take away 9 is equal to 30 people, and I'd say see lines on graph. And if I really, really, really wanted to make sure that I was thinking, oh, hang on, I don't know if I've got given quite enough information here, I could say at 20 mins, 9 people completed. At 30 mins, 39 people completed. Difference of 30 people. Diff of 30 people. Okay? Okay then, so similar shapes. Again, we've seen quite a lot of this recently. It says, right, the first thing we should do, as soon as I read the word similar, it says, did I read the word similar? Okay, how do I know it's similar? In terms of the fact it said enlargement, that means it must be similar. The enlargement would be a similar version of what we've seen originally. I would write down, right by the side of this, straight away, line small times scale factor equals big. Area small times scale factor squared equals big, and volume small times scale factor cubed equals big. Okay, so the first of this question, it says the height of the original shape is 1.6 centimeters. The height of the enlarged shape is 3.2 centimeters. The area of the original shape is 5.2 centimeters squared. Find the area of the enlarged shape. Okay, so the way I do that is I know that the height here is 1.6, and I know that the height here is 3.2 centimeters and centimeters. So that means I can quite clearly see what the scale factor is here without doing too much maths. It's 3.2 divided by 1.6, which is equal to 2. So I know that the scale factor, let's say scale factor equals 2. Now it's pointless me doing all that working out again because I've already done it up at the top. Okay, so to find the area, it would be the small one, which I'm told the original shape is 5.2, times by not 2, but 2 squared. So that is going to be 5.2 times 4, which I still don't know what the answer to that, and this is a non-calculated paper, so I'm going to double it and double it again. Double it, I get 10.4, double that again, get 20.8 centimeters squared. Okay, the main misconception there is going to be that people don't times by the area squared. Okay, and 15a, factorize 16q squared minus 25. Okay, at first glance, it looks like there's no number that goes into both 16 and 25, and there's no letter in both. But this is the trick to spot these are that these are both square numbers. Oh, lost my camera. Just trying to get it back now. One sec. There we go. Back in the room. Okay, so the key thing to notice are square numbers, and also we're now on question 15. It's not going to be really, really obvious at questions 15. You expect it to be harder, okay? So a number that goes into both doesn't happen. We're expecting to see double brackets here, okay? So what goes in the double brackets? Well, if you square root the 16, you get 4q and 4q. 4q times 4q would give me 16q squared. And then square root the 25 gives me 5. So I get 5 and 5 there. And when we say it's the difference two squares, one must be plus, one must be minus. So then I get plus 5 times minus 5 will give me minus 25 as required. But when I get 4q times by minus 5, I get minus 20q. And here I get plus 20q. So they just cancel out. Okay, so the difference of two squares. And the way I spotted it was that both numbers were squares. Factorize 4q squared plus 3q minus 10. So the way that I've been teaching you is that we times the front two numbers together to get minus 40, and we add whatever the middle term is, so positive 3. So a pair of numbers that times together to make minus 40 and add together to be 3. Now I know it must be one of each sign here, and the reason why I know that is they times to be a negative. The only way you can times to be a negative is you get one of each sign. So I'm thinking for a pair of numbers that times together to make 40. So what about 10 and 4? Now 10 take away 4 is 6, so that's no good. So now I'm thinking maybe 5 and 8. Now 5 take away 8 would be minus 3, so it's not quite right, but I'm pretty much there now. It's going to be plus 8 minus 5. That's my combination. So what we've been doing next is we've been saying to just drop just the squared from 4q and put it in both brackets, and then you put in a plus 8 in one and you put in a minus 5 in the other. Okay, so my plus 8 from here, that came in over here, and my minus 5 here came in over here. Okay, if you can cancel, you must. So is there a number that goes into both? Yes, and cancel down by the biggest number, not 2, they're both even, yes, but 4 goes into both of them. So q plus 2 if I divide by 4, and that one doesn't, 4q minus 5. And then that should be it, done and dusted. Do a quick check, q times 4q is 4q squared, plus 2 times minus 5 is minus 10. If those two work, the rest of it will work, I'm sure. It then says, hence simplify 16q squared minus 25 all over 4q squared plus 3q minus 10. So basically they want us to use our answers from part A and B into C. So I'm going to change that to being 4q plus 5 and then 4q minus 5 all over q plus 2 and 4q minus 5. Okay, now is there anything that's on the top and on the bottom? Yep. And because they're times, you can just divide effectively the top and bottom by 4q minus 5, but they just cancel out. And I eventually get left with 4q plus 5 over q plus 2. No cancelling now because they're not timesing anything on the top and the bottom. Okay? Number 16, it says, make h the subject of the formula. So I need to expand both these brackets and then get all the h's on one side and then get rid of anything that's got h in it. So 10h minus 20e on both, and I'm going to have 7h minus 7k. Okay, now I'm going to take anything with h in it all on one side. So I'll bring that over and I get rid of this one here. So I'm going to have 10h minus 7h is equal to 20e, now turn positive, minus 7k. That will then become 3h equals exactly the same thing. And now I'm going to take the 3 over to get 20e minus 3k, all divided by 3. All good? Okay, number 17 will be in the spec paper. It says the perimeter of pattern 6 in the form A plus root B, where A and B are whole numbers, show you're working. Okay, so little things to spot out here. Look at the pattern numbers and look at the answers we're going to get. Okay, now you're just using Python here. So A squared plus B squared equals C squared. So in our terms, we're going to get 1 squared plus 1 squared, which is just going to be 1 add 1, which is 2. And then you take the squared over. So if I write that down here, actually, 1 squared plus 1 squared equals C squared for this top one here. So I'm going to get 2 is equal to C squared. So that must be root 2. Okay, so this is root 2. So we now know it here is also root 2. Okay, so that was for pattern 1. For pattern 2, I'm only focusing on this bit of the right angle triangle. So I'm going to have 1 squared plus root 2 squared equals, I'm going to call that D squared, just so I've already used C squared. Okay, let me try and move the camera. So from there, I'm going to get 1 plus, now root 2 squared, so I'm just going to cancel the squares. So I'm going to have D squared is equal to 3. So that would be root of 3 is equal to D. So I'm going to have root 3 here. Okay, so that means this was root 2. In fact, I can write it in here, root 2. Now this would be root 3. Again, that would be root 3. So if I work now on pattern 3, and I'm going to call that A squared plus B squared is equal to, let's call that E squared then, just as we've already used C and D. I'm going to have 1 squared plus root of 3 squared is equal to E squared. So I'm going to have 1 plus 3 is equal to E. I'm going to have E squared, sorry, 4 is equal to E, and then I'm going to bring around the squared as a square root. Now, I know I can actually go and answer that, okay? I'm not going to because it's going to mess up my pattern if I write it as 2. I'm going to leave it as root 4 at the moment, okay? So that one's going to be root 4 as well. And hopefully, what you'll start to notice is pattern 1, 1 and 1, then root 2. Pattern 2, root 3. Pattern 3, root 4. Pattern 4 is root 5. If you go and do all the working, you will see that it is root 5 there. Okay, so the perimeter of the first one, because that's what it's asked me to find. It's asked me to find the perimeter of pattern 6. Okay, so the perimeter of pattern 1 would be 1 plus 1, which is 2, then this root 2, so 2 plus root 2. For pattern 2, it's going to be 1 plus 1, so that's 2, plus 3, so that's going to be 3 plus root 3. I don't need that 2 in there, it's just inside, okay? It's not the perimeter, the perimeter is the distance around the outside. This one here for pattern 3, 1, 2, 3, 4, 4 plus root 4. In our case, that would actually be 4 plus 2, which is 6, okay? But if I take the root 4 out of it, it's maybe not quite as easy to see the pattern. And then this one here is going to be 5 plus root 5. So the pattern number, whatever it is, you always just go 1 up and you put it as the A plus the root B. So for pattern 6, so I'll just write that here, pattern 6, I'm going to have 7 plus root 7 as my answer. Okay? Okay, then without even reading anything of the question, I've already noticed this really important statement here. So I'm going to write the formula that I've been told to learn, which is FD equals F over CW. Okay, then, so now I'm going to read the question. It says, as a part of an investigation, the time taken to complete an obstacle course was measured for pupils in a group of, or for each pupil in a group of 14-year-olds. The results are summarized as below. Use the histogram to calculate the number of 14-year-olds in this group. Okay, so the number of is a posh word for frequency. I need to get frequency on its own from that formula. So I'm going to take that divide by CW over and it will become a times by. So CW times by FD, the frequency density, will be equal to the frequency. So the group, or the group width or the class width here between 0 and 10 is 10. And then it has a frequency density of 3. So 3 times 10 would equal 30 people in that bar there. Okay, this one here would be 4 times 10, which is 40, then 50, then 60. But this one here, be a little bit careful if we've got a frequency density of 2, and the class width this time is actually 20. So this one here is 40. And histograms, they're designed to be the area is the same amount of people, no matter where they are, no matter how long they took. So if you look at this bar here, 40, it looks like it's just been turned on its side there, doesn't it, for the other 40, and that should be the case. To go and actually work out now how many people there are altogether, I just need to add them all together. So I've got 30, add 40, add 50, add 60, add 40. Now if it was me, I'd just be looking for little number bonds. So I can see that's 100, and then 30 and 40, 70, add the 50 is 120. So it's 120 plus 100, which is 220 people. Okay. For part B, it says draw a histogram to illustrate the distribution of on the graph page below. So we need to work out the frequency density. We need to work out class width. So class width here, 0 to 10 is 10, 10 to 20 is 10, 10, 10, last one 20. Okay, so the frequency density is equal, and I'm going to write that formula here again. Frequency density is equal to frequency divided by class width. So that is going to be 10 divided by 10, which is just 1. This one will be 20 divided by 10, which is 2. 30 divided by 10, 3. 4. Last one, 100 divided by 20, which is 5. Okay, so now it's a case of drawing that in as a histogram. So I've got one as my first one up to here, go afterwards, and then 30 was 3, wasn't it? And then 40 was 4 on the frequency density. And then for the last one, which spanned 2 of them, and remember it was 5, not 6. So you're all the way to the end. So now I'm just going to draw those lines in. Okay, so there's my histogram. It says find an estimate for the distribution, find an estimate for the median. Now the median is the middle value. So in this group, there's 200 people, okay? So 200 would be a middle value. So 200 people, see what I'm writing there, sorry. 200 people divided by 2 would be 100, and that is what we call the median person, okay? So I'm looking for where the 100th person is. So if I start adding these up, the first 10 people were between 0 and 10. So I'm way off the 100 because I'm adding these together. 60, 40 would now be 100 people, okay? So I'd expect the 100th person to be right at the end of that category. Now, if you notice here, it's got right to the end and maybe right to the start of the other category, but they're the same number. And it will always be that case that it will turn out to be at the end of a category like that. So the median person, I would have expected to equal 40 seconds. Okay? State a reason which of the two groups is quicker on average at completing the obstacle course. Well, if I looked at the other one, the 14-year-olds and 18-year-olds. Sorry, can I get these both on one screen? Maybe not quite. The fact that I can see in this graph here, it is peaking in the middle between 20 and 30. And I look at this one, it's peaking at the end between 40 and 60. It's telling me that the first group were quicker. Okay? So I would say, state a reason for my answer, I would say the 14-year-olds, because graph peaks at, don't write at signs, so it's a bad habit of mine, at 20 to 30 compared to 18-year-olds who peak at 40 to 60. Hence, they take longer. Hence, on average, I'd expect the others to be quicker. Okay. Number 19. Okay, ones like this have been coming up in the mocks. It's a good one to look through. It says a cylinder with base of radius x centimeters and height h centimeters has the same volume as the cuboid with its length x, width x, height x plus 2. Find an expression for h in terms of x and pi simplifying your answer. This is a very good question to do in revision. We may look at this in class, okay? So even though you're going to think, oh, I've seen this question in class, you should know how to do it, okay? But it's easy to get this one wrong. It's not an easy question by any stretch of the imagination. Okay, so I'm going to draw it to begin with, cylinder, and then cuboid. Okay, so base of radius x. So that is x, and then this would be height h. Okay, so this one here, the cuboid, has length x. It has width. It has width x. Now my picture looks absolutely nothing like it's 7. It's not a problem. It's just a little sketch just to get me going and thinking what's going on. And then this one being x plus 2. Okay, so I'm told that they are equal. It has the same volume. So I know the volume of this cuboid, which is x multiplied by x plus 2, is equal to, now the volume of this cuboid would be base area times by its length, or words to that effect. What is the constant cross section? Well, it's a circle, so it would be pi r squared. So that would be pi times, now the radius is x, and it's the x that's squared, not the pi that's squared, just the x. Okay, and then you times that by h, so that would become times h. Okay, so x times x would be x squared, and then I'm going to get rid of the times signs to have plus 2 here, and have pi x squared h. Okay, then I'm going to expand this out again and get x cubed plus 2x squared is equal to pi x squared h. And then finally, last bit I've got to do here is just get it in terms of h. That means get h on its own. So I'm going to take over this pi x squared over to the other side. And you can see here we get x cubed plus 2x squared. And then that is all over x squared pi x squared. Now, I've just realised that maybe it was a mistake to expand that out. I assumed it was going to be the case, but can you see I've got x squared here, and then I've got an x cubed, which is higher than x squared, and an x squared here. So I'm going to turn this top line back into its simplified form. So I'm going to turn it back to x squared, and then x plus 2, and then pi x squared here. Now, because these are timesing by each other, that is times that, and that is timesing pi, I can cancel the x squared out there. Effectively, I'm dividing the top and bottom by x squared. So that goes to being 1, that goes to being 1, which leaves me as a final overall answer as x plus 2 divided by pi is equal to h. Okay? 20a, write down a value of where x is greater than 1 for which x to the power 3/2 is rational. So rational meaning integer divided by another integer. Okay, so any number, point number, apart from stuff like non-repeating numbers, so like 0.1 recurring, that is actually a rational number because you can write it as 1/9. But stuff like pi, like 3.142, whatever it is, that isn't rational because it's going to go on forever and ever and ever. Okay, so basically this means, it means that x is square rooted, and then I cube that answer. Now, if I chucked in 1 to any power is always going to be rational. It doesn't matter what the power is. For 1, it will always be 1. So for this one, I just need to pick a square number because I know when I square root it, it will be rational, and then that number cubed will also be rational. So any square number, I'm going to just say 4. So 4 square rooted then cubed would be 2, and then 2 times 2 times 2 would be 8. Okay, so write down a value of x for which x to the power 3/4 to 3/2 is rational. Say x equals 4. That's my answer. Okay, find the value of root 200 minus root 2 squared. There's a couple of ways you can do this, but the way we seem to favour in our class is root 200 minus root 2 squared means times by itself. So write it like that, and then expand that. Okay, so I'm going to do this one times that, which that's just going to give me 200, and then this one times that is going to give me minus root 400, and then minus root 2 times that would be minus root 100, and then I'm going to get minus times by minus is plus 2 there. Okay, from there we know that's going to be 202, but this root 400 we might slip up on. Can you spot a square number that goes into 4 times 100? So that's going to be like the square root of 4 times by the square root of 100, which is actually 2 times 10, which is 20. Okay, if you didn't know it, just take away 20, take away another 20. So then 202, take away 20, take away another 20 would be, well, what's 200 take away 20? It'd be 160, 162. Okay, so 162. Express 0.541 as a fraction. Okay, so what we do, we set it out quite cleverly. We say x equals 0.54141, blah, blah, blah. It's just the 4 and the 1 that's repeating. And the reason why I left a line is because however many dots there are here, I'll times by 1 and that many zeros. Like, so there's 2 dots, be times by 100. If it's 1 dot, times by 10, 3 dots, times by 1,000. So 100x equals, and you must line up your equals and your points. If you don't, you'll mess it up, I promise. Okay, so times by 100 will shift these two along. So that'll become 54 here. And then that 1 will now be above the 5. But then we'll have 4, 1, 4, 1, and so on. Okay, so now we subtract those two things. And we are going to, well, try not to go through your answer like that. Line up the decimal point and the equals again. 100x take away x is 99x. And then these ones here will cancel, 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 cancel until we get to 1 take away 5. Now, 1 take away 5, strictly speaking, is -4. So we try not to have it like that. We borrow 1 from there. So we get 11 take away 5, which is 6. And then 3 take away nothing is 3. And then 5 take away nothing is 5. So we get 53.6 equal to 99x. So x is equal to 53.6 divided by 99, but I will not get my 2 marks if I leave it like that, because I've done something I shouldn't do. Shouldn't have fractions and decimals in the same form. Okay, so the way I'm doing that is just times the top and bottom by 10. So I get 536 over 990, and it's fine to just leave your answers that unless it said you must write it in simplest form. Okay. Okay, number 21 is now off the spec. Number 22 looks to me like probability without replacement. Okay, so it says a box contains 2 strawberry yogurts, 4 vanilla yogurts, and 6 cherry yogurts. 3 yogurts selected at random from the box. Calculate the probability that all 3 selected are vanilla. Okay, so if I take one, there goes the yogurt. So I've now got 1 less. Take another one, I've now got 2 less. Okay, so if I take one, it's gone. Okay, it hasn't said without replacement, but the fact it's number 22 should be telling you that it's out without replacement as well. This is laid down the paper. This isn't a true A-star topic. Okay, so what's probability I can get a vanilla one? I've got 4 out of, so I'm basically just doing vanilla branches here. I'm not going to bother doing the others because I'm not even interested in them. So what's the point in doing extra work? So I'm basically interested in that format there. So I've got 4 out of, what have we got? 4 and 6 is 10, add the 2 is 12. So 4 out of 12. Don't cancel that fraction, just leave it as that's fine. Then, because I've taken 1 vanilla, that would be 3 out of 11. And then, because I've taken another one, it would be 2 out of 10. Okay, now, actually, I've changed my mind. It might be worth cancelling down these fractions to times them together to make it slightly nicer. Although, mind you, what's 12 times 11? 12 times 11 is 132, and then times by 10. No, it's fine, it's fine. You can cancel it down if you want to, but it's up to you. Does it ask in simplest form? No, so it's absolutely fine to leave your answer as a long, big answer without being simplified down. So 12 times 11 is 132, times by 10 is 1320, 1320, and then 4 times 3 is 12, times that by 2 is 24. The alternative that I could have had, you don't need to cancel that down, you'll get the 2 marks for that. The alternative I could have had was a third, times by 3 over 11, times by 1/5, and I would have had 3 times 11, which is 33. But then 33 times 5 is not particularly obvious. It's 165, and then that would be 3 over that, and that should cancel down that. Okay. Okay. Calculate the probability that at least one cherry yogurt is chosen. Okay. So you've got to work smart on this. If you don't work smart, it'll be too hard. We don't want to have branches coming off saying strawberry, vanilla, and cherry. We're interested in cherry or not cherry, and that'll only give us 2 options, which makes it a little bit easier. Okay. So cherry, not cherry. And then again from here, cherry, not cherry. Okay, so from here, what's the probability I get a cherry? Well, 6 out of 12 and then 6 out of 12. So even chance. I could have said half and half, but I can just keep it as fractions. If I go and get a cherry again, it's 5 out of 11. This will be 6 out of 11. Remember, the fraction should add to 1. And then here, chance I get a cherry, 6 out of 12. Sorry, 6 out of 11. Listen to my own advice. And then 5 out of 11. Okay, so there's two ways I can do this. I'm going to go for the obvious way rather than the sort of trick way. The trick way is to say, well, I'm interested in at least one, so I'm interested in this one here, here, and here. This is what I'm not interested in. So, well, if I know all probabilities add to 1, so if I find that one in whatever that one is, take away from 1, it'll tell me what the final answer is, but I'm going to do the more intuitive way. So 6 out of 12 times 5 out of 11 will give me 30 out of 132. And then this one here would be 6 out of 12 times 6 out of 11, which would be 36 out of 132. And this one here would be 6 out of 12 times 6 out of 11, which is 36 out of 132. So then the chance of me getting at least one cherry is all those added together. So 132 plus 36 out of 132 plus 36 out of 132. So 36 out of 36 is 72. Add the 30 would be 102 out of 132. Okay. Finally then, are we on to the final bit? Yeah, because the last bit is vectors and vectors off the course as well. So we have got transformation of graphs. 3f of x, when it's outside the bracket, it does what you expect. It stretches that graph. It's like me picking this graph up and stretching it like parallel, like an accordion from the x coordinates, okay, from the x axis. So it's going to be a steeper version of that, okay? So that's 3f of x. If it was 5 of x, it would just be steeper again. This one here, when it is inside, it does the opposite of what you think. It's inside is move left or move right. You would assume adding 6, you'd move that way, but you don't. You do the opposite of what you expect, so it's actually going to move it to the left 6 ways. You can see that it's currently going through the origin, so it's going to look exactly the same. But this time, that's going to be -6. Okay? And for the last one, a load of writing. Okay, it says y equals h of x. On the same diagram, such curves y equals minus h of x. Now, when it's minus, it's a reflection in either the x or the y axes, and it's actually a reflection in the x axis when it's outside. Okay, so that would be roughly what minus h of x would look like. Sorry, can you see that? And then to get minus h of x minus 1, it's going to move it down 1 point there. So this here would be minus h of x minus 1, and it would be going through minus 1 because originally it's going through the origin. Okay, all done. Hope that's been useful. Let me know in class if you'd like me to do another one before the exams. Okay, thank you very much.